Okay, so I have given you a brief description of what is lateral load and how can we compute this kind of load, no, using two methods. Okay, so karon akong isa-isa ho noon sa pag use sa different methods. So we have the portal method and the cantilever method. So let's start with the portal method. The portal method is a method of computing lateral loads on building frames for building frames that have a low elevation. So applicable siya sa mga buildings, no, mga buildings nga low og elevation, dili kay siya habog. So dili kayo siya subjected to bending. Pag gamay ang pag mubo ra ang imong building, okay, so mayroon ka og frames. Frame is a combination of columns and beams, and it is assumed na each joint niya are fixed. Okay, we have column AD, DG, EH, no? We have beam DE, beam EF. So it is a combination pero fixed siya. When a structure is when the structure has low elevation, ang pinaka subject gid niya nga load is shear, di ba? Kung kuan siya, kung taas ang imong structure, once nga lateral loads or sideways nga loads are applied, at first murag atong una-unaon nga mo bend siya. So that is for the cantilever method na, no? Say for example, you have this building frame. When loads are applied, lateral loads are applied, if taas og elevation, inuna to og 10 meters, then 10 meters ni. So ang tendency niya is instead nga pag push niya, makat siya dire due to shear. Ang mahitabo saya is mo bend sa siya. Okay? Naibending. Move siya, mabend siya. Pero kung ang imuhang elevation is short, pag apply sa load, automatically na shear nga mo react, and it is assumed at the center of the structure. Okay, so this is the steps in computing lateral loads using portal method. So first, it is assumed that hinge is placed at the center of each girder and column and considered to be the point of zero moment. So again, kung mag-hinge ka, di ba? Bisag sa simple support lang nato nga mga beams, ang hinge has a zero moment. Na siya'y mga horizontal and vertical reactions, pero wala siya moment. So it is assumed daw na sa center sa itong mga columns and beams are internal hinges. Second, at every floor level, okay, so mag-cut ta dire internal hinge, di ba? Katong mga example na to sa una sa internal hinge sa beam, pwede ta mag-cut into separate structure. So at every floor level, shear and interior column hinges is twice the exterior. Okay, so the interior ko, no, nga column hinges is twice of the exterior. So say pasabot ana, if you have a load here, shear sa kaninga column GD, so twice the exterior. So let's assume this is X, because this is the exterior. This is also an exterior column, assume as X ang yung shear. Then at the interior column, twice siya, so this is 2X. Okay, gets ninyo? Then the repod, let's denote it with Y. Ang shear force, we have Y here, and an interior column 2Y. Okay. Then after plotting, no, kuha tong shear. So let's cut the last step in portal method is to cut at hinges. Mag-cut ka sa hinges and compute axial and shear starting from left to right. So from left to right, then from up to down. Magsugod gid ka dire sa upper left. Okay? So ito siyang i-apply, no, para mas masabtan na to. Let's say you're given with a frame, this frame, no, and then we have to compute the shear and the axial load for each hinges, and then let's compute the moment at A, moment at B, and moment at C. So again, so tipo maagi, kuhaon sa nato first ang mga shear. Because when we cut, kung wala tayo isa ka available nga load, dilit na to makuha ang uban. So at least na tayo isa ka given, which is the shear for the portal. At least na kay shear. So at mag-start na sa ibabaw, we have the 20 kilonewton is equal to X plus 2X plus X. That is summation forces horizontal equal to 0. Okay. Then makuha na to si X. So compute, we have 20 is equal to 4X. Then X is equal to 5. Then 2X is equal to 10. So we have a 5, a 10, and a 5 here. Okay. So next. So, pwede na ka mag-cut dere. Okay. Then to have a shear of 5 and then 20 kilonewton here. So mag-sum up kag moment sa portion kung asa wala gi available nga forces. Okay? So again, pag push sa 20, mo push sa 20 dire. The axial load at inato kani siya, no, A, B, C, D, E, F, G, H, I. So ato po din siyang dinotan ang mga letters para masayon. H, I, E, F, G, H, I. This is J at point na diri a J, K, L, M, N, O, P, Q, R, S. Sakto ba? Wala naman ito na miss, no? Okay. So at point O, the axial load here, so may direction dapat na to, it must be downward. Birahon niya paubos ang kaning portion to resist 20 kilonewton, di ba? Pag tuklod ana, dapat na downward nga mo pugong para dili siya mabira. Kay kung upward ni unya kanipod is towards the right, so ang rotation nimo tanan is parihas clockwise, so maibot gid ni. And then the purpose of the loads here is to resist the external load. Okay, so it must be downward. Okay, nagets ninyo? Okay. So, summation moment at R equal to 0. Diri ka mag-sum up moment. So, ano to? O vertical. Okay. So, O vertical times pila ni? This is 4 meters. That is half, no? 4 meters. And this is 2.5 meters. Still half. So, OV times 4 nababaylain. Wala na, no? Kaya kani di man ni makarotate. So, is equal to 5 times 2.5. So, O vertical have an interior axial 5 times 2.5 divided by 4. We have 3.13. The next, so eventually makuha na po nimo ang load diri ah. So ana na lang no para sa yon. Ang style sa akong mga classmates sa una bungkagon nila og lagyo. So you have 20 kilonewton, balag wala mo nagtipid sa papel, basta dali lang ninyo ma-analyze. Then dere di na sumukay pod. Okay na. So summation forces vertical equal to 0. Sum up pag force diri OV is 3.13. Therefore ang imuha kong vertical load diri must be opposite. So that is 3.13. Summation forces horizontal, that is 20 minus 5. We have padong dito nga 15. Okay, so nakuha na nimo tanan axial load dire. Tabok na po ka dire pikas. So kung unsa dire towards the left, kani towards the right pod, since this is compression, di ba? Compression. Axial load could be compression or tension. Shear, direction lang ito naon. So the shear for O is 5. The shear for R is 3.13. The axial load tensile for point O is 3.13. The axial load compression, di ba, tension kani compression for point R is 15. So upward, this must be downward. Again, unsa ni? So 2x, that is twice the 5, so that is 10. Okay, then kung magbutang ka og centroid, mo na centroid 8. So pareha sila 8. So ang centroid na to na dris tunga. Sakto ba? Pareha sila 8. Okay, so nasa center. Murag walay rotation na, sige lang. So ito atong i-assume nga downward gihapon ni. Okay, itong i-assume lang nato kay wala man, di man ta makakita og rotation ani nga distance. Okay, so this is P vertical. So summation moment at S, no? Summation moment at S equal to 0. So we have P vertical times pila distance ani 4 meters. This is 2.5 and this is 4 meters. So P vertical times 4 moment at S. It's Unsa pa may lain? Plus 3.13 parehas sa mga counterclockwise, no? Times 8 is equal to, ito pa may lain, wala na, no? So kanina lang 10 times 2.5. So P vertical pila? So 10 times 2.5 minus 3.13 times 8 divide 4. So this is 0.01 negative. So this is approximately 0. So wala dahil kay kundri 0 ni. So sakto pud, no, kay sa ni pagpugong nga naman diri ang centroid, pag tuklod niya kani ang mupugong downward o kani pud na mupugong upward to resist the rotation sa 20 o sa 30 sa centroid sa tibuok frame. Okay. So, summation forces vertical sa may direction na ni PV 0, 13. So, this is upward nga 3.13. No? 3.13 plus 0 is 3.13. Summation forces horizontal 15 o 10. Therefore, nakay 5 po din nga para mo resist sa 15. Okay. So, diri na po kaspikas. This is compression 5 and a shear downward 3.13. And then another available na to nga load is the X, which is 5 ang shear. Shear at point Q. Shear at point Q. Okay, so summation moment at S equal to 0. 5 times 4 is equal to kani upward ni. Ano man, kung diri ka upward ni siya, ang rotation na to is counterclockwise to resist the clockwise nga 20 kilonewton. Okay, so Q vertical times adili mali day 5 times 2.5, then Q vertical times 4. So makuha na to si Q vertical 5 times 2.5 divided by 4, 3.13. Okay. Okay na. So nakuha na to tanan axial and shear for the upper side. So the next is proceed to dire. Diba? From left to right, then from up to down. So kani, this is tension 3.13. This is shear opposite ani nga direction 5. Then here, upamanita kakuha sa Y. Di ba? Karon kay diri naman ka nga portion, so unsa may gi-resist niya? Okay, so ang gi-resist is the dual ka loads, the 20 and the 30. So again, we have 20 plus 30 is equal to Y plus 2Y plus Y. Diba? Diri sa ubos, duha na yung resist. So we have Y plus 2Y plus Y. Then Y is pila? Compute. 20 plus 30 is equal to 12.5. Okay. So this is 12.5 na shear. Shear at J. Shear at J. So, nakuha na po na to. Sum up moment, summation moment at M, no? At M para makuha na to ang axial dire morning M equal to 0. Again, this should be tensile. Okay. Ang rotation sa imong mga loads is clockwise. It must have a counterclockwise sa imong structure. So, downward J vertical. So, J vertical times pila ni 4. This is 2.5. This is 2.5. So, J vertical times 4. So, pa may laing counterclockwise. Wala na, no? Wala na. Is equal to 12.5 times 2.5 plus kani 5 times 2.5 plus 3.13 times 4. So makuha na to si kani si 50 din na ni ka-rotate. Okay, along the line naman siya sa M. So J vertical is, okay, so solve using your calculators. $14.07. Sakto ba? Okay, so this is 14.07. Okay. So, computon po nimo ang point M. Summation forces vertical, that is 14 minus 3.13. So, upward po ni to resist the 14.07. So, 14.07 minus 3.13, we have 10.94. Okay, so murag kung ano kanida ay is 3 meters kay 6 manini. Okay, so mautro ni siya. JV times 4 is equal to 12.5 times 3. Then 5, same, 2.5. 3.13 times 4. So nanay nga may nga changes na to. So 12.5 times 3 plus 5 times 2.5 plus 3.13 times 4 divided by 4, we have 15.63. Okay. Summation forces vertical 15.63 minus 3.13. 15.63 minus 3.13. We have 12.5. So 12.5. Okay. So summation forces horizontal, we have 50 plus 5 is minus 12.5. 50 plus 5 minus 12.5. We have 42.5. Mali na punta dari. This is 30. Diba? 20 to 30. So, delete na po ni 42.5. So, 30 plus 5. 35 minus 12.5. We have 22.5. Okay. So, kalibog-libog na kita, no? So, ilang. So, with constant practice, makuha ra gyapon na to na siya nga accurate. So, make sure nga sakto gid atong mga nabutang dire. Katong 50 dire, total nanto niya. Applicable na sa pagkuha sa value sa y. Okay. So, nakuha na itong mga loads. Pagkabot na po dire, nag-cross na siya. Okay. So this is 22.5 and this is a downward na 12.5. This is upward na 0. Then opposite sa 10 diri nga side. This is 12.5 dire. Put dili 2y dire, 2y. So 2 times 12.5, we have a 25 here shear. Okay. So summation moment at n. Okay. Summation moment at n equal to 0. So saan man na? Summation moment at n. So akan ni assume na to downward gihapon ni. This is K, no? K vertical. So K vertical times 4 meters, 4 meters. This is 3 meters. Dito na sa kay na. And this is 2.5. 2.53. Okay. So K vertical times 4 plus sa pamilaing counterclockwise sa n 12.5 times 8 to 4 pabilain wala na no is equal to 25 times 3 plus 10 times 2.5 pareha sila clockwise plus 0 times 4 which is 0 na po. Okay. Wala na ba? Okay. So K vertical is equal to 12.5 times 8. Dili. Kanya itong nahon. 25 times 3 plus 10 times 2.5 minus kani 0 naman eh. 12.5 times 8 divide 4. So 0 gyapon si K vertical. So makasum up na tao forces vertical and horizontal. So summation forces vertical for the shear at n, we have 0 plus 0 0 minus 0 pero na kay 12.5. So this must be upward 12.5 to resist this one. Okay. Summation for the axial axial load, summation forces horizontal pila ni 22.5 plus 10 minus 25. Sakto ba? Dito plus dito minus padulong pikas. So 22.5 plus 10 minus 25, we have 7.5, which is padulong dire 7.5. Okay, so dire na punta. Kani opposite sa 7.5, then opposite of 12.5, which is downward. Then we have y 12.5. Kani downward nga Q vertical 3.13 and then pikas pod nga 5. Okay. So summation forces vertical, no? Kay kanira may unknown na to, which is upward. Summation forces vertical 3.13 plus 12.5. So we have 15.63. Okay. So last, dali na ta sa point A, then at B, and at C. Okay, so manlang nabilin sa to A, si B o si C diri sa foundations niya nga fixed. Okay, so kung nakay 12.5 dito, opposite nakay 12.5 po dire. And upward nga 15.63. Upward nga 0. Then opposite sa 25, which is paganglong diri A. And then kani po diri opposite 12.5. Then downward nga 15.63. So if you are asked what is the moment at A, that is 12.5 times 3 meters, which is half of your 6 meters. Half of your 6 meters. 3 meters, 3 meters. So moment at A is 12.5 times 3. So you have 37.5 kilonewton meter. Moment at B is 25 times 3 meters. We have 75 kilonewton meter. And moment at C is 37.5. So, ang questions for portal is magtuyok lang sa pagpangita no sa imuhang mga axial and shear for each hinges, and then the moment diri mga moments, diba?